Question 10. Given triangle ABC, so you have to make a triangle. It's on the book. Triangle ABC. The median is BF. So BF splits the ground of the triangle in half, because the median that goes from one point to a side cuts that side in half. So therefore, BF is the median. So therefore, AF is equal to FC. I wrote that over here. AF is equal to FC. And question 10. Given triangle ABC with a base of AFEDC, or just a base of AC. That's the two ends of the base. The median, that means the thing that cuts the base in half, is BF. This line over here that I'm going to make green. And the altitude is BD. I'm going to make that blue. The altitude is what makes two separate right triangles. It breaks this triangle into two separate right triangles. And BE, which I'm going to do in black, line BE bisects angle ABC. It bisects angle ABC. That it makes BE makes the ABC into two congruent angles. It splits angle ABC in half. Which conclusion is valid? Answer 1, angle FAB, that's angle FAB, is equal to angle CBD. First of all, that's not true, because you know that BE bisects that angle, and therefore D is between E and C, and therefore that does not bisect the angle, and therefore you know that they're not equal, because it says FAB is equal to, again, FAB is equal to ABF. We have no reason to say that. How would we know such a thing? And also, answer 2, ABF is equal to CBD, also not true. CE, line CE is equal to line FA. We know that's also not true. No, we know that the answer 4, which is CF, which goes up, F is the middle of the bisector, that's the median that breaks the ground into half, is equal to FA. We know it's true, because this is half, and this is the second half, because BF, this breaks it in half. So the only answer that is correct is answer 4. Question 10. Given triangle ABC with a base of AFEDC, the median is BF. So between A and C, the middle of line A and C is F. So what is true? So the only one that's true over here is that F is the middle between C and A. So CF is equal to FA, because F is the middle of it. And if they're equal, they're congruent. All the other ones, we have no proof for it. and therefore the only correct answer, the only one that could be correct, that we know for sure that's correct, is answer 4, that CF is equal to FA, because F breaks the line into half, that FA and FC are both equal to each other. Question 11. In the diagram below, circle O has a radius of 5. So it shows you circle O, and it shows you from the middle of the circle, and O is represented as the middle of the circle because it has a radius of 5, because it says from O till point A, which is the end of the circle, is 5, and we already know it has a radius of 5, so you know that this is the radius, 5, and you know that O is in the middle of the circle. Now, also, CE is equal to 2. They made a triangle over here, and they told you from point C to point E is 2. That means the radius is 5. That means from the middle to the end of the circle. This is also from the middle to an end, so that's also 5. So if this is 5 and you subtract 2, you're left with 3. And the question is, what is the length of BD? From B to D, what's this length? Well, let's figure it out. You could tell from here that you have two similar triangles. That's one way to do it. And first, let's figure this out. A squared plus B squared equals C squared. Let's make this A. Let's make this B. And we'll make this the hypotenuse C. So A squared is 3 squared plus B squared equals 5 squared. So 9 plus B squared is equal to 25. Subtract 9 from both sides. B squared is equal to 25 minus 9 is 16. So the square root of B squared is equal to B. And the square root of 16 is equal to 4. So therefore B is equal to 4. And a small b, I'm just making ABC for the Pythagorean theorem. No connection to the circle itself. And if B is 4, so we know that if you have a diagonal that goes through the circle and it's perpendicular to a chord, line BD is a chord because it doesn't go through the diagonal. It is not a diagonal and it stays inside the circle. Something that's like that is a chord. And if it's perpendicular, it tells you that's perpendicular. It says that diameter AC is perpendicular to chord BD. So if it's perpendicular, you have a right angle. If you have a right angle, so then the diagonal cuts the chord into half. So if from the middle of the chord to D is 4, so then this is also 4. And the question is, what is line BD? So it's 4 plus 4, which is 8, which is answer 3. Question 12. What is an equation of a line that passes through points -3, -11, and is parallel to a line whose equation is 2x minus y equals 4? Well, the answers they give you, y is equal to something. So let's make this equation that we're asking about y equal to something. So it's negative y. Is 2x minus y is equal to 4. Get y by itself. So 2x minus y plus y gets rid of the y on the left side. And whatever you do to one side, you have to do to the other. So you added y to the left side, you add y to the right side. You got a y on the right side. And you want to get rid of the numbers on the right side. So positive 4 is on the right side. Subtract 4. You just have a y on the right side. And subtract 4 from the left side to keep the equation equal. So 2x minus 4 equals y. Now, what equation is this similar to? The slope of a line is what x is being multiplied by. Over here, x is being multiplied by 2. Meaning, when x is 1, y is 1 times 2. When x is 2, y is 2 times 2. When x is 3, y is 2 times 3. So that's the slope. If these two things, these answers 1 and 2, have the same slope because x is being multiplied by 2. Answers 3 and 4, x is being multiplied by a half. Answers 3, x is being multiplied by a half. And answer 4, x is being multiplied by a negative half, and that's a line that would be perpendicular. If you would write x on one thing, if you would make an x over here, and you make a graph, right? And you would do y equals negative a half, y equals a negative a half times x minus 25 over 2, you would see that when you get these points at the end, when you get x, y, you would have a line that's perpendicular to the line of 2x minus y equals 4. So therefore, to get it by itself, to find a line, so these two answers are wrong. Because first of all, 4 is perpendicular, and 3 is a half of x, is neither perpendicular nor parallel, it will intersect. Answer 1, it's either answer 1 or 2. So let's plug answer 1 into the equation. Remember, x, y. X is negative 3, y, x is negative 3, and y is negative 11. So let's see if this is true. Negative 3 times 2 is negative 6, plus 5 is negative 1, is not equal to negative 11. So you know that answer 1 is not correct. Let's plug this point that the line that's parallel to 2x minus y equals 4. Let's plug in x and y in that this line is supposed to go through into the equation. So x is negative 3, y is negative 11. So 2 times negative 3 is a negative 6. Says minus 5 is equal to negative 11. So therefore, answer 2 is the only correct answer. And a lot of times, when you have answers with numbers, all you have to do is plug the answer back in, and you should get the right answer. Question 13. Line segment AB has endpoints A and B. A is 2, negative 3. So I went 2, then down negative 3 is point A, and point B is negative 4 on the x-axis, and up 6 on the y-axis over here. Now, what are the coordinates of the midpoint? Well, the midpoint is you add the two x's together, and you divide it by 2, and you add the two y's together, and you divide it by 2. So, what I did is, I made point B x1, y1, so do negative 4, and x2 plus x2 is 2 over 2, comma, and the y's are, what's y1? y1 is 6 plus a negative 3 over 2. So let's work this out. We'll put the final answer over here. Negative 4 plus 2 is equal to negative 2 over 2, which is for the x, and the y is 6 minus 3. 6 plus negative 3 is 6 minus 3 is positive 3 over 2 is 3 divided by 2 is 1 and a half. 1 and a half or 1.5. We'll see what the answer is. Now, this over here, negative 2 over 2, can be simplified. 2 divided by 2 is 1, but it's an odd amount of negatives. It's negative 2 over 2, so it's negative 1. So the final answer is the midpoint of this line segment is x negative 1, y 1 and a half, which happens to be answer 2. Question 14. What are the center and radius of a circle whose equation is x minus a squared plus y minus b squared equals c squared? Well, what's the center? The center is the middle of the circle. The radius of a circle is represented as c squared, and the x, y points are represented as a, b. X is a, y is b. So if the center of a circle are at points a, b, so then the equation would be x minus a squared, because instead of positive a, it becomes a negative a. So x minus a squared plus y minus b squared equals c squared. And over here, the radius is c. So it says that, doesn't say what the radius is. It asks you what the radius is. So if this should be equal to c squared, but it tells you that it's equal to c, so therefore, since it tells you that it's equal to c, so x minus a squared plus y minus b squared has to equal to the radius square. If the radius square is c, so the square root of that is the radius. So the square root of c is radical c. And that answer happens to be answer 2. That answer happens to be, it does not happen to be answer 2. Its the center is AB, and the radius is radical c, which is answer 3. Question 15. A rectangular prism has a volume of 3x squared plus 18x plus 24. Its base means its length. Remember, a rectangular prism is a box, because a prism is, when you shine a light through the prism, usually it comes out in different colors. A prism is a box. It's three-dimensional. Length times width times height. It makes up the volume of the prism. So the volume of this prism is 3x squared plus 18x plus 24. Its length is x plus 2. So you make yourself a box. You don't have to make a box. I'm just showing you. X plus 2 is the length. The width is 3. It tells you. And it asks you which expression represents the height of the prism. Well, the only thing we don't know is the height. So you could have taken one of the four answers and plugged it in. But we're not going to do that for now. Now we're going to try to solve this. We know that volume is length times width times height. We know the length is x plus 2. So for length, we'll put an x plus 2. Times the width is 3. Times the height is the unknown. And it's equal to 3x squared plus 18x plus 24. So you know when you divide this, you're going to get out of it x plus 2. And you get a 3. And you're also going to get what h is. How do you break it down? Well, you know that there is divisible by 3 because you have a 3 over here. And you also know that 3x squared and 18x and 24 are all divisible by 3. So take a 3 out. 3 times x squared is 3x squared. 3 times 6x is 18x. And 3 times 8 is 24. So therefore, this is the same thing. 3 times x squared plus 6x plus 8 is the same thing as 3x squared plus 18x plus 24. And we know that it's equal to length is x plus 2 times the width is 3 times the unknown height. Now, can you factor this out? Yes, you can. X squared plus 6x plus 8. You would have had to factor it out before you. But since we know you have a 2x, so when you write x gives you x squared. You know one's a 2. So the 8, one of them has to be 2, the other one has to be 4. So therefore, it's also the 8, it has to, when you multiply the last, you get an 8, and you add up the x's, you're supposed to get a 6x. So let's try, 8 we know is divisible by 2 and 4. So let's do x plus 2 and x plus times x plus 4. We know that one of them is x plus 2. So the other one has to be x plus 4. You already have the answer, but let's just try it out. X times x is x squared. X times 4 is 4x. 2 times x is 2x. So 2x and 4x gives us 6x. And the last is 2 times 4 is 8. So you know this is true. Now, divide both sides by 3. The 3 disappears. Divide both sides by x plus 2. The x plus 2 disappears. So we're left with height is equal to x plus 4, which is answer 1. Question 16. Lines K1 and K2 intersect at point E. Line M is perpendicular to lines K1 and K2 at point E, where lines K1 and K2 intersect. Now, which statement is always true? Well, let's see. What do we know? We know that you have line M, and line M is perpendicular to lines K1 and K2, and K1 and K2 intersect. That means you have this plane over here, and lines K1 goes this way, lines K2 goes that way, and then there's a line like this which is perpendicular to them, so it intersects both of them, So the only way for it to intersect both of them if it's perpendicular to the plane that they're on. One goes like this, one goes like that, so they make up a plane. And the theorem is if a line is perpendicular to two intersecting lines, then it is perpendicular to the plane they determine. Determine means because length and width make a plane. Also, two lines that are not the same line also make a plane. A line that's perpendicular to both of them is perpendicular to that plane. So we know that line M is perpendicular to the plane that line K1 and K2 is on, because line K1 and K2 intersect each other. So line K1 and K2 are not, lines K1 and K2 are not perpendicular to each other. They're not parallel to each other. And since line M is perpendicular to them, so therefore lines K1 and K2 make up, lines K1 and K2 make up a plane because you have, let's say, length of the plane, like length of the board and width of the board makes the board. Now if something sticks out straight out of the board, giving you a 90-degree angle, so therefore that line is perpendicular to the board. Line M is perpendicular to the board that has lines K1 and K2. So which statement is always true? Let's try answer 1. Lines K1 and K2 are perpendicular. They're not perpendicular because they might be perpendicular, but we don't know if they are or not, because they could intersect at a 30 and 150 degrees. They can intersect in any way. They can also be perpendicular. But that's not always true. Answer 2, line M is parallel to the plane determined by lines K1 and K2. The only way to be perpendicular to both lines that are intersecting is to be going off the plane and determining space, the third dimension. So therefore, it can't be coplanar. It can't be on the same plane. This is the only reason why it's drawn like this, is because you can't have something sticking out of the regions. So answer 2 is not correct. Answer 3, line M is perpendicular to the plane determined by lines K1 and K2, we already said is the correct answer. And answer 4, line M is coplanar to lines K1 and K2. That's not true because lines K1 and K2 are on one plane and they intersect. The only way to something to be perpendicular to both of them if it's not on the same plane. So the only correct answer is answer 3, that line M is perpendicular to the plane determined by lines K1 and K2 because of the theorem. If a line is perpendicular to two intersecting lines, then it is the plane they determine. Again, theorem. If a line is perpendicular to two intersecting lines, then it is perpendicular to the plane they determine. Question 17. In the diagram below, PS is tangent to circle O. PS, over here I made dots, but on the region there's no dots, but it's PS is tangent to circle O, means it touches it at only one point, and PQR is secant. Is a secant, means it goes through the circle. And we only deal with the outside from point P till it goes through the end of the circle and not beyond the circle. You never deal beyond the circle. Now, PS is at the end of the letter. PS is equal to X. And PQ is equal to 3. And PR, which is the whole secant, is equal to X plus 18. Now, what is the length of PS? What is the length of the secant? Well, let's first figure out what a secant is. If you have two secants, one secant is equal to the other. I mean, if you have two tangents, one tangent is equal to the other. If you have a tangent and a secant, so the way it is tangent square, means tangent times tangent, is equal to the part of the secant outside the circle, starting at point P, where the tangent also starts, they have to start from the same point, otherwise it's not going to work. And they'll always start from the same point on the region. So it starts at point P, goes to point Q, so that part times the whole secant, meaning from point P till the end of the circle, means where it's about to leave the circle, but not beyond the circle. So again, it's the secant square, tangent square is equal to the part of the secant outside the circle times the whole secant, meaning from the point you started till where it's about to leave the circle, and that's how you work it out. Well, we know the part outside the circle, the secant outside the circle is 3, and the whole secant, which you're multiplying by, is x plus 18. So, and we know it's equal to tangent square, which is x squared, because tangent is